Welcome to lecture number 13 of CS 527. So, as I have announced previously that this week I'll upload three lectures, but later I have decided to upload only two lectures. So, I'll only cover selective topics from this last chapter. The last chapter is chapter number 12, that is concurrent programming. So, from this chapter, I'll only cover the concept of thread, how to write multi-threaded programs. Only that part I'll cover. The initial 2 3 sections I'll not cover. For example, this 12.1, 12.2, these two sections I'll not cover. I'll directly go to 12.3, and for exam purpose also you no need to study 12.1 and 12.2, but there are some interesting concepts written in these two sections. So if you want for your knowledge, you can definitely read these two sections. So basically in these two sections, what it is doing the continuation of the previous eco server that we have developed in the previous chapter. The same thing they are modifying in these two sections, and they are also trying to find out, explaining the disadvantage of using multiple process for each request and how thread will be better. Okay, so we'll start from 12.3 directly. So what you need to do is you have to read this section. So please follow these lectures. Whatever topics I'll discuss, only the on how to I'll mention these topics will be required to study. Basically, you need to study from 12.3 to most of the part of this chapter. But once you understand the basic concept of thread, remaining things will be very easy for you to understand. Okay, so as I'm starting from thread, basic concept of thread. So the very basic concept of thread, I think it's known to you, right? So it's called a lightweight process, or the difference between thread and process you already know from the course of operating system. And if it is not very clear, what I will do today, I'll not explain the basic difference between, means the difference between threads and process in detail. I'll just explain it in short, but it is your responsibility to understand it properly. So if you have any doubt between regarding the difference between process and thread, either read this section properly, or you may also go to internet, or you can also go to some operating system book and try to clear it. So difference between process and thread is part of your syllabus, but I am just explaining the most basic difference. Basic difference between thread and process is, in process, if you go for a fork command, then it's create a child process, and the parent process and child process have completely different address space, right? But this is not true in case of thread. When you go for thread, then when one thread creates another thread, then all the threads are part of a particular process. So each thread, if I go, it is written here. So in case of thread, each thread has its own thread context. Means thread context means which include thread ID, stack pointer, program counter, condition code, general purpose register, values, all these things. So I think these concepts are really clear. What is called stack in a process? During the when I was discussing process, I explained you stack. Stack means where the local variables are stored, right? And if you declare a variable, or if you allocate a memory using a malloc command, that is called dynamic memory allocation, right? So that it's stored actually in heap, not stack. So I hope you know the difference between what is stack, what is heap, and all these things in terms of process, not in terms of data structure. Okay, so in threads, each thread has a separate thread context. So what are the things which is separate for each thread? Thread ID. Each thread has a thread ID, stack pointer, program counter, condition code, and general purpose register values. These are different for each thread within a process. But which are the things that is common? One of the most important things, the thread share the code. Complete program code is shared among the thread, and also the heap is shared. So means the complete virtual address that is allocated to a particular process is shared among all the threads of this particular process. So again, if you remember, when we execute a fork command, it create a complete different child, right? And now there are two process, and they have complete independent address space, which is not true in case of in threads. Threads are within a particular process, and they share some all the address spaces of that process. So you have to remember this thing, that what are the things that all the threads shared within a particular process: the heap, This is the main important thing, and the shared library code data and data areas and all. So if we need to discuss that how thread executes in a real machine, it's almost similar as how multiple process executes in a real machine. Because if there is one thread and from one thread that thread creates another thread, and now there are two threads, then in a real machine these two threads can execute concurrently. If there is only single code, then they will work in concurrent manner. If there are multiple code, they may also work parallelly, right? I hope you know the difference between concurrent and parallel. I think I have explained it during the initial days of this course. So now if we assume that there is only one core available in your process and there are multiple threads, then it means that how these threads will execute. In actually only one thread can execute at a time, right? But since when one thread will execute, if that thread needs to load something or there is some input or operation required for that thread, then it will go to sleep mode, and that time another thread will be loaded. So in this way, that is called multi-threading, right? And in the same code, multiple threads will execute. So how threads, suppose in code one, in a particular code, thread one is executed. After this, maybe at this point, this is time. So at this point, if thread one will go, it need to go to sleep mode because it has some input output operation. So the core can execute another thread, which is thread 2. So from thread 1 to thread 2, when this is called thread context switch, means core 1 is executing here thread 1. So now to execute code thread 2 by core 1, there is a context switching required, and that is called thread context switch. Okay, and then here the thread 2 is executing. After some time, maybe again thread 1 will execute. So the core will switch from thread 2 to thread 1 again. So in this way, concurrent thread execution is possible in a single core. And if there are multiple cores and there is no dependencies, then maybe two threads can execute in parallel also. And if there are multiple cores, so all these things you can try by yourself, because at the beginning of this course I have explained you that how you can limit the number of cores of your machine, right? That I have explained you. There is a command that if there are four cores, you can limit it to only one core. So maybe what you can do, you can run a multi-core program and only run one core of your machine and see the performance. Then you run multiple core, activate all the cores in your machine, and then try to run a multi-core program, see the difference of performance and all. I'm not explaining all this thing in detail because all this thing I've already explained when I was explaining you the concept of process and all. So core binding and all already I've explained you with a practical example. So that's why I'm going a little bit fast here. So I'll directly start with POSIX thread. Its main POSIX thread is we also called as P thread. It's a standard interface for manipulating threads from C program. So it's, or you can in simple language you can say that if you want to implement multi-threaded program in C, then you can use this library P thread. So that part is very very important for this course, that you should know how to use P thread and you should know how to write multi-threaded program. That is a major requirement of this course. So I'll start with this program. So instead of typing this program faster, let me just explain it from here. So you can ignore this line number one header file instead of this header file, because this, you know, this is a library. And so what actual header files is required, because if you go to CSF, there are a lot of other header files, right? So which are required for this particular program. For this particular program, you need only two header files, three header files, I think. One is pthread.h, because you are using pthread. So you will use pthread.h first, and two are the most common. One is stdio.h and std library.h. These three header files will be enough. Okay, and then this is your main program. So in main programs, as same as process ID, you have to use a variable. This variable pthread underscore t is defined in pthread.h. It's better. Let me write the header files here. Dir.o. These are the libraries required. So replace line number one with this here, and then remaining things is same. So pthread underscore t is defined in this header file pthread.h. Okay, so here this is a variable where we can store a thread ID. And then line number 7, it is calling pthread create. Ignore the capital P. You can, this is a adapter function defined in this library. So if you are not using this library, go for small p here, pthread create. I will explain this function. Pthread create will create a thread for you. Okay, so if you relate line number 7 with the concept you know from process, then it's similar as fork. So when you are calling fork, immediately it is creating two process, right? That is not happening here. Pthread create is a function which will create a thread, but when the new thread from where it start execution is depend on you. In case of fork, immediately from line number 8 both process started executing, right? But it's not the case here. In case of pthread, you here you are supplying tid. It's a call by reference because there is a value. So pthread will create a thread, and the thread id will be set here, so that the parent process, or you can say the creator thread, will know the thread ID which it has created. Okay, so this is the call by reference value. Here we pass some thread parameters. So throughout this course, or throughout this thing, this syllabus, we'll set null here. Okay, and this is important. This thread is called pointer to a function. Pointer to a function means the p thread, like now it will create a thread, and the thread ID will be returned by this tid, and the newly created thread will start executing from this function, and the pointer of this function is this. So suppose this function is this. So the once you create a thread, the newly created thread will start executing from this function, line number 12. So that is mentioned here, that which if you create a thread, from where it start executing, it should be a particular function, and pointer of that function should be passed here. So this is the pointer of that function, and this is null. Here you have to pass the argument. For example, if this function, you suppose you want to create a thread, and this particular, the moment you create a thread, it should work on some initial, it should you have to pass some initial argument to this thread. So that argument you can pass through this null. So this is one through which you can pass argument. So you can collect these arguments here, and then you can start executing. Okay, so now let us try to understand this particular code. So it is a variable. So here I'm creating a thread. Okay, so after this line, a new thread will be created, and that the ID of this new thread will be now assigned to tid because of this. And then the new thread will start executing from here. So the new thread will print hello world, and it will return null. Okay, and then the parent thread, what it is doing, parent thread will wait here. Pthread join is same as the wait function of the process. So here the parent thread will, after executing this, so there are two threads after line number 7, right? So parent thread will not execute here. Only the child thread will start executing from line number 12. Parent thread will execute pthread create, and then it will come here directly at line number 8. And here pthread join will call. So pthread join means it will wait here for this thread tid. So what is tid now? Tid is the id of the newly created thread. So here at line number 8, the parent thread will wait for terminating of the thread, the child thread, right? And then after this, it will reaping, or it will reap all the resources allocated to that particular thread. So this is same as the wait pid or wait command of process, where the parent process has waited for the wait for this termination of a child process. And once the process terminated, and it's caught, means capture this termination here, it will delete all the necessary resources reserved for this that child process. The same thing is also required here, that if there is a thread, and so we can say it's, there is a joinable thread. So I will explain you what is called joinable thread later. So if there is a joinable thread, so every time when a process create a thread, when one thread create another thread, then that newly created thread is called a joinable thread. So for that joinable thread, if it terminates, then it is the responsibility of the thread who has created it to or any other thread. It's not just who has created, maybe any other thread, to delete all the resources that is reserved by that thread. Okay, the logic is same as I have explained for while I was explaining zombie process and all. So that's why it is I am the parent thread is waiting here, pthread join tid. So when this thread will be completed by return null, then here the pthread will execute this line is this line will return from here, and then the main program will exit. Okay, so here the parent thread is not printing anything, right? Only the child thread is printing hello world. So I'm not running this program because it is very easy. You can write this program, but remember line number 2. Line number 2 is also important because this is called function prototype or function declaration, which is also required because you are defining your function here, not here. So declaration and definition, I hope you understand all these things. And this is a pointer to a function. Sorry, this is a function, and here you are passing a pointer to function. Okay, so one more thing, if you want to compile your any program where you have written a multi-threaded program you have written, like this program, if you want to compile it, then you have to write gcc file. For example, the name of this file is file1.c. Then you have to use minus p thread. Without this, your program will not compile. So I hope all this thing is clear. Then let me go to this scroll this book and explain some more basics about threads. All these program functions that is used here. For the first function is how to create a thread. To create a thread, the function name is called pthread create. I have already explained, right? Previously, in previous example, it was showing capital P because that was the adapter function for this CSF library. But the basic function that is written in pthread.h is this pthread create. And in pthread create, first is a call by reference, and you have to pass a variable of which has to a variable of type pthread underscore t. So purpose of this is this function will create a thread, and the thread ID will return through this variable. Then pthread attributes mostly will use null for this, and then pointer to a function that this is the pointer of the function from where the newly created thread should start executing. And the argument, argument means the list of arguments or list of values that you need to pass to this function, uh, from which the newly created thread will start its execution. Very simple. You can read all the details written here, but explain all this thing to you. Then anytime if you want to know the id of a thread of that particular thread, then you can call pthread self. If you call pthread self, then it will give the id of that particular that particular thread. Terminating a thread, terminating a thread means you can call p exit and thread id here. So from any thread you can call any other a pre exit. So the thread terminates explicitly by calling pre exit function. Okay, so if the main thread calls pre exit, so the main means from any thread, if you want to exit the terminate the thread, you can call p thread exit. So if the main function is, or for example, if we go here in this code, and if I write here pthread exit here, then what will happen? This thread will wait for terminating all the thread that is created by this main thread, and then only it will that will exit. That is written here. If the main thread called pthread exit, it waits for all other paired threads to terminate, and then terminates the main thread, and the entire process with the return value. Okay. And sometime if you from any thread, if you call exit function, because it's very common, right? We write exit 0. So it's a linux function, function exit function. So if we do this, exit means exit the process, right? Exit function is related with process. So the moment you write exit 0 and it executes, the process will be deleted. So if process is terminated, that means all the threads inside that process will also terminate. Okay. Another peer thread, one peer thread can also cancel another peer thread by calling this p thread cancel and by thread id. So in this way, one peer thread can terminate another peer thread. The reaping that terminated thread, that I have already explained, means if it's a thread, when we create p thread creates a thread, it's a joinable thread. Joinable thread means every time when a joinable thread exits, its resources will be there in memory. So it's the responsibility of one of its peer thread to remove the resources. So that's why any other peer thread should call p thread join with the thread id of the terminating thread, so that it can remove the resources of this. So this all these things are almost similar to a zombie process. Okay, but there is one more thing is called detaching of a thread. So as I said, at any time when we create a thread using create thread function, so the pthread create function, then that the thread newly created thread is a joinable thread. But sometimes we can detach the thread also. A joinable thread can be ripped and killed by other thread. So in memory, its memory resources are not freed until it's ripped by another thread. So that I've already explained, right? But in contrast, if the thread is a detached thread, then it cannot be killed by any other process. Okay, and so every, and that if a thread it's a detachable thread, then it means that when that particular thread will terminate, then all the resources will be automatically removed. So how to make a thread detached? Because every time initially every thread when it's created it's joinable thread, right? So for this you have to call a function. This function pre-thread detach and the thread ID. So if you want to make a particular thread as detached, then you have to call this function. So it means that any thread can detach any other thread, and if a particular thread wants to detach himself, then it can call pthread detach, and is here instead of thread ID, it can write pthread self, right? Pthread self return the thread ID of the same thread. So all these things, all these functions are important, and this function is also important. It initialize the thread only once. So you read this, I'll not explain it, but this is also simple. So and now this next thing is a concurrent server based on thread. So basically what they are doing here, here they are using this multi-threaded concept to make this eco server that we have discussed in the last chapter. So I'll not explain most of the thing because the most of the thing here is same. Only thing different is here. This is the server, eco server. This is the only thing different is here. Well, uh, you can see client FD is fine. Then here connection FD is except a connection FD is there. Let me open this file again. So here I'm deleting all these things. You know what which other files are required only specifically for thread. For this server network, other header files are required. For that you already know. So now if you remember the code, if the previous chapter code, what we are using, there was a while loop like this, and inside this while loop, first of all we are going for client FD. Uh, uh, for example, no, sorry, we are directly going for suppose connection FD, and then we are going for accept, right? And then after this what we are going for echo, I think, right? Echo, and then with this connection FD we are going for this, and after returning from it, the while loop will again execute like this. That's this almost similar, there was a code. So if you remember, you can understand that after this connection has been established, and when this is going to echo function, this server was not ready to accept any other request, because now the control is in echo server, echo function, and it can only accept another client request, another client when it is returned from echo. So in your in your the third assignment, I think, or in fourth assignment, I think, quiz, fourth quiz, I have given a question that how you can make this, change this code such that it can be ready every time, it can ready every time for a new connection. So at that time I expect that you should do it using a fork, so that there are multiple, there can be multiple process, but how to handle it and all. So that was a possible way, but maybe not completely a accurate way to do this. The best way to do this, best way to make a server is, a real server is, there is a server, there is a thread which is always ready to accept a new connection. The moment it get a new connection, it will create a separate thread to communicate between that particular client with the server. And then again the main thread will go here and wait for another connection. Okay, and again another thread, then another new connection comes, then it will again assign to a new thread, and the original thread will again go here. So in this way, every time the main thread is ready to accept a new connection. That is exactly doing here. If you see here, after this accept line, it is calling a thread, and that thread is executing from here. This is a thread, so it is creating a thread, and this connection FD is passing to this thread. And again the main function, and the main thread is again from here immediately going to this, and it is ready for another client request. So there are two three small minute things is need to be observed here. First thing is detach. If you see here, they will be detached this thread, I think, yeah, line number 31. So they are detaching this thread. Why? Because you can see here this parent thread is not waiting, or not waiting for this child thread to terminate. So you have to detach this thread, because you know the property of the detached thread is, it when it's terminate, all the resources will be automatically removed. This is the first thing. One more important part here, you can see that the value that it is sent here, there is a malloc here. If you see these two lines, you will not see in your code, in your previous last chapter code. In last chapter code, there will be integer thing here. Instead of a pointer of this, there will be integer connection fd, right? There will be integer connection fd, integer connection fd, and they are using connection fd here, and then going for echo. But what is the problem? Instead of integer, if I go for a single, instead of pointer, if I go for a connection fd, instead of this, if I go for only integer connection fd, then what will happen here? What will happen here? Suppose I'm sending a connection fd here, and so here, uh, after this line, p thread create, the newly created thread will start executing from here, right? And the first line, if you see, first line is there is a local variable here, right? Integer connection fd, and that local variable is collecting this connection fd descriptor here. So since this is a generic pointer, so you have to cast this pointer and collect this value. So these are the basic C concepts. So ultimately, line number 30 is collecting the value that is passing through this variable, right? Connection fd. That is fine. But the problem is, since these two, after line number 23, this thread, main thread, and this child thread, these two threads will start executing concurrently, right? And you have no control, because this scheduling will be dependent by operating system. So you have no control that which order they'll execute. It may be possible that before executing this line in child thread, parent thread will go here, execute this line, and again come to this line, accept, and maybe it will accept another client request. So the moment it will accept another client request, the value of this variable will change. So in this case, if you just go for a global variable like this, then this or the old child may got an old value, means old got a new, means a completely different file descriptor value, not assigned for that particular child. So if I want to explain it in more detail, suppose this is your client one connection, right? Client one requested for a connection first time. When C1 is trying to connect, then the connection fd value will be a value which, through which we can communicate, server can communicate with C1, right? And that connection fd value is passed to here. But before assigning it to this local variable, suppose there is another variable, another client request came here, because this is a while loop, right? So again, so now in the, what will happen, this connection fd value will change, because every time it call for accept, it will give a new value. So the value will change. So after executing this line for this client 2, if the first one, the first thread that we have created start means execute line number 30, then it will get the completely different connection fd. It will get the connection fd of this, because of global value and all. So that's why what the technique you have to follow is, every time what they are doing, before going for any connection, they are going for dynamic memory allocation, and they are using a, see that, that's why they are using a pointer here only. And by allocating a memory here by dynamic memory allocation, and then they are calling the accept function here, and then they are passing this value. So in this case, every time while loop will go here, it will allocate a new memory in heap location, and that value stored in that memory is passing here. So after initially assigning this memory, this value to a local variable here, it is the responsibility of this particular thread to delete that location. That's why it is going for free of this very. So free means the moment I to call free here, the memory assigned here will be free. So I'm not explaining it even in more detail, because more rest of the things are completely the concept of pointers of C. So if you have, I'm assuming that you should understand the remaining concept. Also the complete thing whatever I'm explaining is discussed in this section also. So the main means concept of this section is how to convert your eco server, the previously created eco server, to a real server where each client request can be handled by a thread, and also the main server thread, which is accepting the connection from a client, is always ready to accept a new connection. So all this thing is important. So I have explained. You can run this program by yourself. I'm not running it, because how to run all the basic things I've already explained. So whatever written in this, I have just explained you. So you when you read, you'll understand. Then the shared variable in threaded programs. So this is also important. So since in it's not like multi-process thing, right? As I said, all the threads are share threads within a particular process share the virtual address space. So what are the things? What are the variables that are shared among multiple threads, and what types of variable are separate or in means local for each thread? So if we know C programming, there are normally three types of variable we go for, like global variables, local variables, and static variables within a function. So I'll not go for the details about what is called global, local, or static, because you know it from your C concept. So a global variable is shared by all the threads because it is defined within a process. So a global variable is any variable. A global variable is any variable declared outside of a function. At runtime, the read-write area of the virtual memory contains exactly one instance of each global variable, and it is shared among all the threads. Local variables are not shared. Local variables, each thread has its own local variables, okay, and they are stored in the stack part of each thread. As I said, each thread is own has its own stack, right? I have explained it at the beginning of this lecture. So all the local variables are stored in the stack. So if we go back to your this code, then see here, I think if I go back to this code where I was explaining the echo server, then this local function connection FD, it's a local variable, right? So this will be local to each thread. So first connection when established, there will be this thread which will execute this. Second time when a next connection will be established, the peak thread create will create another thread, right? So it will be thread number three. So thread number three when start executing, then for this thread number three, this FD connection FD will be a local variable, and local variable means each thread had its own local variables. So I hope this point is also important and you should understand it. So that is written here how global variable, local variable, and static variable are considered in multi-threaded environment. Again, the local static variables are also shared by all the threads. The remaining thing you read from here, you will understand it. So what do you understand by shared variable in multi-threaded environment? So a shared variable means which is visible to all the threads, and all the threads can access it. Maybe it can update, read or write on a particular variable. So these type of variable is called shared variable for all the threads. Okay. So if a particular variable is shared by all the threads, then there may be some issues that we have to handle. So suppose if there is a variable which can be updated by any of this program, then it may create some problem. So let me show you an example, then you will understand what kind of problem is possible. So this is a simple multi-threaded program that I have already written. So this is the function prototype, which the function that will execute by every new thread that will create by pthread create from the main function. So this is the main function. This is command line parameter. That is very easy. So this function is accepting a particular value from the command line parameter, and what it is doing here, there is a global variable here called cnt, right? There is a global variable called cnt, and this value is incremented by both the process, both the threads. So how? See, step by step, if I explain this code, very easy code. Header files are there. Line number 4, there is a global variable I've defined, cnt, initial value is 0. This is the function prototype for thread function, and this is the main function. So main function, there is a variable called n. Then there are two variables t1 and t2. They are for thread ids, and then n equal to r2e argv I means the value a integer value that will pass from the command line parameter that will be stored in n. This is simple, right? If I pass 400 will be stored in n. If I find, so I supply 500 from the command line parameter, 500 will be stored in n. That's it. Now line number 11 and 12 is creating two threads. 11 is creating a thread which will the thread id will be stored in t1, and 12 is creating another thread whose thread id will be stored in t2. But both the thread, after creation, they will start that execute the same variable, sorry, same function, thread function. It's not different. Means see, 11 and 12 both are, after generating the thread, the new thread will start executing from this function, and in both thread we are passing the value of n, both threads. So if we just concentrate on line number 11, it's creating a thread and it's passing a value of n. So after line number 11, parent process will start executing 12, but the child sorry, parent thread will start executing 12, but child thread will start executing from line number 19. So in line number 20, there is a local variable n, and the value you are passing through this, that means if the value of n is here 200, then the value will be assigned to this n from here, right? And then what this thread is doing, it is incrementing the global variable cnt n number of times, incrementing the global variable cnt, and that's it, and nothing else. So if you see the overall program, what it is doing, there are two threads, and you are passing a value. For example, if you pass a value 200 here, then what it is doing, and there is a global variable also as defined in line number 4. So first, there are two threads we are creating at line number 11 and line number 12. So the thread of line number 11 will increment the cnt variable n number of times, and the same thing is doing by line number 12 also. Line number 12 also increment the same global variable 20 times, sorry, n number of times. So suppose now I will give you a example, that if you assume that the value of n is 4, suppose the value of n is 4, what will be the output here? Means after creating two threads, and then after terminating through the threads, here I am updating or printing the value of cnt. What should be the value? If a value of n is 4, then what is happening, the initial value of cnt is 0, so thread 1 is incrementing it 4 times, and thread 2 is again incrementing it 4 times, so the final value should be 8, right? So every time if I give the value of n is, if the value of n is 20, then what will happen, what should be the value of cnt? It should be the if the value of n is 20, then thread 1 is incrementing it 20 times, thread 2 is incrementing it 20 times, so 20 plus 20, 40, so final value should be 40. So let me execute this program. If you have not understood this program, just take a screenshot, means you can pause the video here and try to understand what should be the output. I've already explained, but it should be clear to you before moving next, to understand the concept that I'm explaining here. So if I open a terminal and I uh, compile this code, minus p thread, okay, if I run for 20, final value is 40, right? No issue. But if I run it for 2000, final value is 4000, final value is 4000, no issue. If I run it for 20,000, final value is not expected, right? And it may change every time. See, sometime it is expected. If I, because if you supply 20, the final value should be 40. If you are supplying 2000, final value should be 4000. If you are supplying 20,000, final value should be 40,000. Sometime it is coming, sometime it is not coming. So what is the problem? This is a very simple program, right? Very simple program. Where is the problem? See, every time I'm executing this program, it is not giving me expected result. It is giving me very odd results every time. So it means that if if you have not controlled your multi-threaded program properly, the complete output will be different, and it will not be correct. So the error here is depend, if you want to understand the error here, then you have to understand the assembly language code, and there should be a basic knowledge of complete computer architecture is required. So I'll quickly explain it to you why this error is coming, and this is a very interesting thing. It is written in book also, but I'll explain it in my own way. So let me open a notepad. Okay. So only important point here is the line number 22, whatever, which is we are incrementing a variable. So if we want to increment a variable, this is the C program, right? So when you'll convert it to assembly language code, how this line will be converted? At least three line is required. First line is load CNT. You have to load it from memory. Then you have to update it, right? You have to update CNT. I'm not writing any syntax of any exact assembly language. I'm just trying to explain it to you, and then store CNT. These three things is required, right, for updating this. You have to load the content of CNT. You have to update it, and then store. Load, update, and store. Three assembly instruction is required, right, for every thread. So there are two threads here, so three instruction is required. So what will happen here is, suppose in thread 1 there are two threads, right? Thread 1 and thread 2. So for thread 1, if and thread 2, suppose if I write thread 2 here, thread 2, okay. So now in thread 1, first of all, I'll go for, this is load, update, and store. So L1, okay, After this L1, then I'll go for U1, and then I'll go for store one. That is fine. Okay, and L1 update one and store one. Sorry, store one. This is fine. So suppose the initial value of CNT is, initial value is 0. So after this thread executing, what will be the value of CNT? The value of CNT should be 1, right? I'm loading the content of CNT. Updating means incrementing the content of CNT and storing it back. So after storing it back, what will be the content of this CNT? Content of this CNT will be again 1, right? So content of CNT will be 1. Fine. And now after this here, if I start executing thread 2, means now I'll load here, then what value it will load? It will load from memory the value of CNT. Which value it will load? It will load this value 1. Then it will update it. Update means 1 will be incremented to 2, and then it is storing the value here, storing the value. So after this line, what would the value here? Value will be 2. That is perfectly fine, no problem with this way. But the problem is, see, these two thread can execute in concurrently, yeah, and you have no control in which way these two thread will execute, because these are the independent instruction of thread 1 and these are the instruction of thread 2. You don't know in which order they'll execute. If they execute in serial order, means after executing these three will execute in atomic order, means these three will execute first, these two will execute last and second, then there is no problem. But if there is a mix, then there will be a problem. How? I'm explaining it now. After executing load 1 here, if you execute load 2 also, and situation is again initialized to 0, suppose, what will happen? What will be loaded in thread 1? Thread 1 value will be loaded as 1, and in thread 2, sorry, as 0, and in thread 2 also value will be loaded as 0. And then now maybe here if I go for U2, and after this if I go here for S2, what will be the value of final value of CNT? Can you guess? Here you can say here load 1 and load 2. These are the two operations performing. If we consider this is the time, this is the time, then both thread, the initial value loaded will be 0 from memory, because what's the purpose of load instruction? Load instruction load the data from memory. So at this moment the content of memory is 0, right? So here also load will load 0 value, this load will also 0 value. So increment here is 0 plus 1, increment here is also 0 plus 1. So this store will also store 1, and this store will also store 1. So final value, instead of becoming 2, it will become 1. Okay, so the same thing is happening here. When I'm writing this, that's why the exact value should come 4000 every time, but it is not coming 4000 every time because of this race condition. Means this shared variable is not handling properly. This is the final if I say final conclusion, why this error is not why this program is not giving expected result, because the what I can say, this is a shared variable and the two threads are not handling the shared variable properly. So how to handle this shared variable properly, that will be discussed in next class. So I'm stopping this here, and if you are interested, you can continue reading this chapter and you will easily understand how we need to control means the how we need to control this thread to handle this share variable properly. Okay, so I'm stopping this lecture here. Next lecture I will continue from this particular program.